Dear students, you have been learning about the solutions of the problems under maxima, minima in the earlier sessions. In this session also, I am going to work out some problems in which I am calculating the local maximum and local minimum values of the functions. The first problem being f of x equal to x by 2 plus 2 by x is greater than 0. That means x takes only strictly the positive values here. Now, what is the procedure here? The usual one. First we calculate the first derivative, then we calculate the second derivative. Take this as result 1. Now, let me find the first derivative. F dash x is equal to x by 2, don't apply the quotient rule here, 2 being a constant, 1 by 2. Now, here keep the 2 as it is. Look at the other term, it is 1 by x. 1 by x means the derivative is minus 1 by x square. So, if you write it properly, f dash x would be equal to plus 1 by 2 minus 2 divided by x square. You have the first derivative. Let me differentiate for the second time. F double dash x, 1 by 2 being a constant becomes 0 minus 2 into one formula I have told you when I was doing the derivative. It is suppose we are having a function 1 over x to the power n. The derivative would be minus n divided by x to the power n plus 1. That is, write the index with a negative sign in the numerator and increase the denominator index of the denominator by 1. So, this would be equal to minus n over x to the power n plus 1. So, the same procedure I am following here also. Here 2, write it as minus 2 and x square becomes x cube. So, the second derivative in this case is f double dash x would be equal to minus of minus plus 4 divided by x cube. Now, this is the second derivative. Now, to know the critical points here, as usual, we equate the first derivative to 0. That is, let f dash x be equal to 0. What is f dash x? Just now we have calculated half minus 2 by x square is equal to 0. Now, take this to the other side, that is, half would be equal to 2 by x square. On cross multiplication, we get x square equal to 4. That means that x is equal to plus or minus 2. So, here I get two values of x here, x equal to plus 2 or minus 2, those are the critical point. But in the function that is given that x takes only the positive values, right? The reason here, since x is greater than 0, x is equal to 2 is the only critical point, Now, at this point, we want to know how does the function behave. Will it be a maximum point or a minimum point? For that, substitute this value in the second derivative. Put x is equal to 2 in f double dash x. That is f double dash 2 would be equal to 4 divided by 2 cube. I already told you there is no need to find the exact value, we are interested only in the sign. Since both of them are positive, the quotient is also a positive number. So, when the second derivative is positive, what is the conclusion? It is attaining a local minimum value. That is, you write x is equal to 2 is a point of local minima. Or you can write it is a local minimum point. Since we are interested in the local minimum value, you have to go to the original function. In that one, put x is equal to 2, you get the value. That is, put x is equal to 2 in f of x. That is f of 2 equal to x by 2, that is 2 by 2 and again 2 by 2, that is 1 plus 1, that is equal to 2. Hence, you write the answer. Therefore, local minimum value is equal to 2. So, this is how we have to find out. Local minimum value is equal to 2 because it has got only one critical point. At that point, it is attaining only a minimum value. Now, let me consider another function. Here, this function is having a term only in the denominator. So, we will be applying the different methods of differentiation and getting the result. Fx equal to 1 divided by x square plus 2. 1 divided by x square plus 2. So, this is the function. See here, you can see that it is in the form of a quotient. So, one method is as usual, you can apply the quotient rule and then get the derivative. But since the numerator is containing 1, a constant, directly you can use the formula 1 by x. See, if y is equal to 1 by x, what's the derivative? It is minus 1 by x square. But here, this being again a function of x, it's a composite function in that case, then you have to differentiate the denominator also. So, let me take it as 1 to know the values afterwards. F dash x would be minus 1 divided by the square of the denominator. In the place of x, I am having this one. But this being a function of x has to be differentiated, whose derivative is 2x. Therefore, the first derivative is minus 2x divided by x square plus 2 the whole square. Now, to get the second derivative, of course, in this case, you see that it is in the form of a quotient, apply the quotient rule. The denominator x square plus 2 the whole square into derivative of the numerator, that is minus 2 into 1, minus of the numerator into differentiate the denominator 2 into x plus 2. It is again a composite function. X square means 2 into x, again x square has to be differentiated, whose derivative is 2x divided by square of the denominator. Already 2 is the index, so it becomes 4, x square plus 2 whole to the power 4. So, this is the second derivative we are having. Now, you need not simplify this one, because our problem is to find out whether the second derivative would be negative or positive at the critical point. So, first let me calculate the critical point. Let f dash x be equal to 0. What is f dash x? Minus 2x divided by x square plus 2 the whole square equal to 0. On cross multiplication, minus 2x equal to 0 implies x is equal to 0. So, is the only critical point. Only critical point. So, in this case, we got only one value. See, in the previous problem, we got two values, but one was, because it was a positive node, we took only one value. Here, we are getting only one critical point. When x is equal to 0, just want to know what would be the sign of the second derivative, right? Put x is equal to 0 in f double dash x. That is, wherever x is there, replace it by 0. So, f double dash 0 would be, look here, it is x square plus 2 the whole square, 0. So, 2 square is 4 into minus 2. So, directly I am writing, it becomes minus 8. And here you observe, see, it is this x square plus 2x, another 1x is there, another x is there. So, and since x itself is 0, so entire thing would be 0, minus 0. Whole thing divided by denominator also it is 0, x square. 2 is positive, so 2 to the power 4, that would be 16. So, minus 8 by 16, you observe that it is negative. It is negative means, what is our conclusion? The function attains a maximum value, local maximum value at what point? At x equal to 0. Therefore, you write the conclusion, less than 0, that is at x equal to 0, the function fx has a local maximum value. See, this sentence can be written 2-3 ways. You can write x is equal to 0 is a point of local maxima, or at x equal to 0 function fx has a local maximum value. Our problem is to find the local maximum value. So, wherever x is there in the function, you substitute the value x equal to 0. Therefore, you write local maximum value. Local maximum value is equal to f of 0, that is 1 over 0 plus 2. Hence, it is equal to 1 by 2. That is 1 by 2 half is the local maximum value the function is attaining. So, when a function is defined directly like this, it is comparatively easier. That means, when the function fx is given, or it can be given y equal to something or fx equal to something, you first find the derivative, first derivative, get the second derivative, afterwards you equate the first derivative to 0, always you get the critical point, substitute those values of x which you have obtained in the second derivative positive minimum, second derivative negative maximum. Okay. Now, I have told you I will be working out some statement problems also. So, when you work out the statement problems, the function will not be given like this. The reading the condition, whatever condition has been specified in the problem, you have to frame the function first, then the remaining procedure is same, finding the first derivative, second derivative, etc. Now, I move on to a statement problem here. Find two numbers. The problem is like this. Find two numbers. Find two numbers whose sum is 24. Whose sum is 24 and whose product is as large as possible. As large as possible. See, this is how the statement problem would be. You have to find two numbers here. What's the condition? Their sum is given to be 24. So, first that's a data. Now, using the second part of the problem, you have to get the result, you have to get the numbers here. Find two numbers. What are those numbers have to be calculated? Whose sum is given to be 24 and whose product is as large as possible. Here I am not using the maximum word. As large as possible means the product attains a maximum value. That is the meaning of that one. So, sometimes it may not be very much clear, vague. You have to read and understand the statement, what is given there. So, sum of the two numbers is 24. You have to find the numbers. First, how do you write? Let x and y be the numbers. Let x and y be the numbers. Given x plus y is equal to 24. You observe here, only the sum is given. So, x and y, both of them are variables here, isn't it? If x is 1, this is 23, 2, 22, 3, 21, like that. So, both of them can have different values, the total is 24. So, when you have two variables, no, how do you differentiate? So, let us write one in terms of the other. Either you can write x equal to 24 minus y, or y is equal to 24 minus x. Okay, any one, both are correct. Any one can be written in terms of the other. Now, here the product has been specified. You can make your own notations. Now, usually we denote a product for P for product and S for something like that. Let P be the product of x and y. P be the product of x and y. That is, P is equal to xy. This is what I told you, two variables are there. But what is y? You write that one. That is x into 24 minus x. Therefore, P would be 24 minus x, 24x minus x square. Now, this is the function. This is the function here. Now, our problem is to find the values of x and y here. The procedure is same. So, we got the function which we have formed now using the condition. Now, x is a variable, differentiate with respect to x. There when the function f was given, we wrote f dash x. Here p is given, I am writing dp by dx, or you can write p dash also. So, this would be 24 minus 2x, correct? Now, go to the second derivative. It is d square p over dx square. D square p over dx square would be minus 2. You observe it is less than 0. Less than 0 means what is our conclusion? It is attaining a maximum value. So, this condition is satisfied. Product is as large as possible. So, when it is less than 0, immediately write the condition, that is the product is maximum. So, our problem is not finding the maximum value here. Our problem is to find the numbers here. Under what condition? When the product attains a maximum value, what can be the respective numbers? That is our problem in this particular problem. Therefore, we have seen that it is attaining a maximum value. So, the second derivative is taken for the confirmation here. Therefore, we have got the values, we have got the second derivative to be less than 0. Hence we are having the confirmation that the product is maximum. Therefore, equate the first derivative to 0. dp by dx equal to 0. What is dp by dx? 24 minus 2x equal to 0. That is 24 is equal to 2x. What does it imply? X is equal to 12. When x is 12, since the sum is 24, y is also equal to 12, isn't it? So, how do you write the answer here? Therefore, the numbers are 12 and 12. So, this is the procedure we adopt. The numbers are 12 and 12. So, read the condition. Sometimes the product would be given to us. So, see, the product of the two numbers is some 18, some number would be given. So, some condition would be given about the sum of the two numbers. So, using the same condition, you can form the function here. So, formation of the function is important. The remaining part is same, that is getting the first derivative, getting the second derivative and equating the first derivative to 0, getting the critical point and also verifying with the second derivative whether it is a maximum point or a minimum point. Now, another another problem, statement problem only. Here also the same condition but with a small difference. Find two positive numbers. Find two positive numbers whose sum is 16. Again, whose sum is 16 and another condition. See, this is the first part of the problem and the data I can say. Sum of whose cubes, CUBES, sum of whose cubes is minimum. So, it is clearly given. It is minimum. So, in the previous problem, the sum of the two numbers were given. The product was attaining a maximum value. So, after confirmation, you have to consider the value. Here, the sum of their cubes is given. Sum of their cubes is given. So, as usual, let me take the numbers to be, let x and y be the numbers, be the positive numbers. Let x and y be the positive numbers. Given x plus y equal to 16. The sum of two positive numbers whose sum is 16. Therefore, you can write y is equal to 16 minus x. Y equal to 16 minus x. Next, this is the data. Now, let us come to the second part of the problem. What is given there? Sum of whose cubes is minimum. That means that we have to find the sum of the cubes of the two numbers. Now, let me denote the S to be the sum of them. let S denote the sum of the cubes of the numbers x and y. That is, let x be equal to x cube, let S be equal to x cube plus y cube. Now, x cube you write as it is. So, y you can replace it as 16 minus x the whole cube. Here, see, if you know the formula correctly, a minus b whole cube, you can expand and simplify the function at this stage itself. Then you can go for differentiation. Or else, as it is, taking this as a composite function, you can do the differentiation. See, both ways you get the same answer. Suppose you expand this one. If you know the formula, it is a minus b whole cube. So, a cube minus b cube minus 3 into a into b into a minus b. A minus b whole cube is a cube minus b cube minus 3ab into a minus b. Now, why I am expanding is this number gets cancelled. Therefore, S would be equal to 16 cube, you write as it is, it is a constant. When you differentiate as it is, it gets cancelled. Now, let me multiply minus 3 into 16 into 16. You can write it as minus 3 into 16 square into x, or else I told you directly also you can differentiate, both are correct. Now, then minus of minus plus 3 into 16 into x, that is 48 x into x, x square. Now, this is yes now. Now, let me differentiate with respect to x, that is a remaining variable. So, this becomes 0 minus 3 into 16 square into 1, derivative of this one, plus 48 into x square becomes 2x. Therefore, let me rewrite this one, ds by dx is equal to minus 3 into 16 square, keep the number as it is, and 48 into 2, that is 96. Now, this is the first derivative. Now, let me find the second derivative, d square s by dx square. First one being a constant becomes 0, 96 into x, that is 96, it is greater than 0. So, when the second derivative is greater than 0, what is our conclusion? The function is attaining a local minimum value. So, let me mention that one. That is you write at x is we do not know the value at present, that is what we are calculating. That is the function is having a local, it is having, you need not write, the function is minimum you write, that is enough, because we are not specifying local minimum or maximum. Greater than 0 because the sum should be minimum, isn't it? So, write the function is minimum because the second derivative is positive. Therefore, let me equate the first derivative to 0. Let ds by dx equal to 0 because our problem now is to find the values of x and y. What are those numbers which would satisfy the condition whose sum is 16, whose sum of their cubes is minimum. So, we have seen that it is minimum. And now, what is ds by dx? Minus 3 into 16 square plus 96x equal to 0. Now, that means that 96x, shifting that number to the other side, 3 into 16 square. It is nothing but arithmetical calculation. X would be equal to 3 into 16 you write, divided by 96. Now, 16 ones are 16, 16 6 are 96, 3 ones are 3 twos are 2 ones are 2 eights. That means that we are having the value of x is equal to 8. So, the value of one number is 8. So, what would be the value of the other number? Automatically that is also 8. The reason is the sum is given to be 16. Therefore, sum of the when first number is 8, the second number would be 8 again. So, when you add them, you are getting 16. When you add the cubes of those numbers, no, that the sum is attaining a minimum value, therefore we are getting the number. So, in the statement problem, this is the simplest statement problem I can say, because some of the statement problems which we will be considering, they would be a little bit lengthy. We may have to draw the diagram and then we have to find the values. Okay. So, in the next session also I am working out some more problems on maxima and minima. Thank you.